Hello, everyone, and welcome to another Open Rewrite / Moderne Community Office Hours. I'm Sam, our VP of Engineering, and I'm alone this week as Tim is on a well-deserved vacation, and I am going to be traveling for the rest of this week, so our usual time slot on Wednesday uh, was not as convenient. So if you saw the change of schedule and showed up here early, uh, great. Glad to have you. If not, there'll be a recording available for everyone else. Just to start things off with a few announcements, uh, we will be we will be presenting a on the Security Boulevard on a how to massively pay down your tech debt on March 28th. So that is this Thursday at 11 p.m. Eastern Time. And so I will just put a link in chat here there we go. A link in chat there for anyone who might want to register to check out this session. As we often talk about on here, we'll be discussing how to leverage the power of automation in order to keep your code up to date with the minimum of manual TDM. Since why should you update your code if you can have our code update your code? That'll be presented by Kevin, who you may not have heard as much from, but he's our brilliant leader of the platform team. So if you've ever used the app.moderne.io interface or one like it, one of our private tenants, this is the work of Kevin and his team. So look forward to that. Also, as I mentioned last week, we are going to be at Dev Nexus from April 9th to 11th in Atlanta, Georgia. So come check out the fundamentals of migration engineering with Open Rewrite as presented by the founders of Moderne, Jonathan and Olga. That'll be a lot of fun. I encourage you to check it out if Georgia is nearby for you. Okay, so those are kind of our announcements for the moment. Since the last one of these we did was only a few work days ago, last Wednesday. We haven't had any new Open Rewrite releases in the interim. Wait, I better put the Dev Nexus link in the chat as well. There you go. So with those announcements out of the way, I thought I would talk a little bit about dependency management with Moderne, which is, we talk a lot about making code changes and how to use things like Java template to change your Java code or your JVM language code. But on almost every situation where you're doing a migration, where you're not just trying to, enforce some best practice within your code, but actually move to a new version of some library or some platform that you run on, you'll also need to manipulate your dependencies. You'll also need to manipulate the the developer tools, the stuff around the code, the code's context. And so I thought we would just take a little time to tour that, to tour both the tools we have available for introspecting into your dependencies, as well as the tools that are available for changing and updating your dependencies, and maybe also touch on some related stuff like doing Gradle wrapper or plugin updates and the like. Okay, so here's our Moderne interface that you hopefully know and love already. And before we change dependencies, maybe we should talk about how to get insight into what your dependencies even are to start out with. It's something that I've had to do fairly frequently as a software developer over the years, is figure out, hey, some version of a transitive dependency is ending up on my class path. What version is it? Is it the right version? Does it conflict with anything else? And so to answer questions about your class path, we have this recipe called Dependency Insight. And you'll see that there's one for Node.js, one for Gradle, one for Maven, and one for Gradle and Maven simultaneously. I'm working on Java projects, so this is what I'm going to be most interested in. And let's say that I had a problem with serialization. And I know we use the serialization libraries Jackson. They're incredibly popular and useful. But I suspect, for example, that not all of our libraries are using the exact same version of Jackson. Uh, and if you have multiple Jackson modules, they all need to be aligned to the same version, or, well, you may run into errors since you're using code with code other than what it was intended to run against. So if I run this, I start immediately getting search results. I'm just running these over the open rewrite repositories on GitHub. And in these search results, I see things like, this build.gradle file is bringing in, Jackson 2.16.1, which is great. And if I, click over to one of these other guys, see this guy is bringing in Jackson 2.16.1, which is good. But if what I'm looking for is a discrepancy, an instance of one of these guys not having the same Jackson version as all the others, well, clicking through each of these, dozens of results is not very practical. So what I want to jump to is either a data table where I could use this dependencies in use to get a spreadsheet or a JSON file or a CSV of all the direct and transit dependencies that are in use. Or even more conveniently, I could run this dependency usage visualization. And let's take a look at this. I haven't actually run this in advance, so I'm going to be curious to see if all of our Jackson versions are aligned. We haven't had any operational issues related to Jackson versions recently. So if there are misalignments, then that will be interesting. Okay, and so what we see here is that there are actually 3 different versions of these Jackson dependencies in use throughout Open Rewrite. Almost everywhere is using version 2.16.11. Oh, and this is called a violin chart, or this gray area around a data point kind of indicates how many data points there are at that version. So we see that we have 291 instances of Jackson annotation version 2.16.1 appearing everywhere. But we have just a couple instances of 2.17.0 being in use. So looking at this, our open repositories are substantially aligned around 2.16.1, but there are a couple that have started to move to newer versions of Jackson. So maybe I want to track those down, and I want to see what is bringing in 2.17.1 only. So I could rerun this, and rather than saying everything, I want to see only 2.17.1. So I can figure out where this new version of Jackson is entering into our dependencies. Okay, that's not what I expected to get at all. Why did I get no? I said that there were some dependencies. Not you. Oh, 2.17.0, and I searched for 2.17.1. User error. Error code pebcac. All right, let's try that again. But this time, I will search for a version of the dependency that's actually in use. It looks like it's rewrite Gradle plugin and rewrite tooling model that are pulling in 2.17.0, which might be fine. So now I have quickly across 40 repositories identified where the discrepancy in my between my expectations of what our dependencies are and what our dependencies actually are is. And so you can easily imagine how if you were getting serialization errors across your dozens or hundreds or thousands of repositories, that this could have quickly helped you to track down where the discrepancies were coming from. Okay, so that's cool. So like you found out that you want to you found out that you have some dependencies and you want to update them or otherwise manipulate them. What can you do about that? Well, we have, much as there are recipes for searching for dependencies, we have recipes for upgrading dependency or plugin version. So let's see, we can upgrade, and kind of similar to before, there's one for Node.js, one for Gradle, one for Maven, one for Gradle and Maven. So let's say here I want to, upgrade. Say I want to upgrade everything. Say we want to upgrade all the Jackson dependencies to latest.release. You can use a number of selectors here. So if I search here, dependency version selector. It's just dependency selectors. It's unfortunate that the documentation search is being slow. I want to say the page I'm looking for is, yeah, here it is, dependency version selectors. We support anywhere you can specify a dependency version, you can use one of these selectors. You can do search for latest.release. Although I need to update this page, latest.integration and latest.snapshot are also available if you want to search for not the latest release version, but the absolute latest snapshot version that's available anywhere. You can use latest.integration or latest.snapshot. You could do a hyphenated range. Say, give me the newest you find between this range of versions. You can substitute 1x of a SimVer version, or 1 digit of a SimVer version number with an X to say, the latest that is, use the latest possible value for the X digit and fix the other digits where they are. So there's a number of selectors here, and you can see all of the examples, but most commonly just search for latest.release. Rather than running this over Open Rewrite, let's go run this over Netflix and Spring. So rather than having to go and manually look up what version I want to use, I'm going to say latest.release to go and fetch the latest version that is available in the artifact repositories that each of these repositories define internally, and we shall see how that upgrade goes. Yeah, and so immediately we start getting back results that include upgrades to Palms, as well as, see if we get any Gradle updates. There we go. So you can start getting Gradle dependency updates as well as Maven dependency updates, which can help keep you up to date with your dependencies across a wide code base. And this is a really commonly used ingredient in migration recipes. So, if you were writing a recipe to move someone from, say, Spring Boot 1 to Spring Boot 2, well, then you need to not just make the appropriate code changes, but also make the relevant dependency changes. So, if I go, for example, and I go into rewrite Spring, oh yeah, I guess one thing I want to point out is that the Gradle, the dependency management recipes that apply to both Maven and Gradle live in this Open Rewrite Java dependencies recipe module. So if you want to take a look at any of those or make contributions, check out Rewrite Java dependencies. And of course, the implementation for the underlying dependency frameworks are in the core rewrite repository under Rewrite Gradle and Rewrite Maven, respectively. When you are trying to write a migration and you do some code changes alongside some dependency manipulations, it is incredibly common to use upgrade dependency and the like. So you'll see, org and open rewrite to Java dependencies, and this is the fully qualified name of the version that does both Maven and Gradle. So you see these all over the place in migration recipes doing version upgrades, and it's very common that we will use the .x notation to take the latest patch version of something, since patch versions are asserted by SimVer to not have any breaking or backwards incompatible changes. So you would usually want to take the latest patch version. So yeah, in our upgrade recipes, that is the pattern you will tend to find. But of course, there's not just upgrading a dependency version. There's also sometimes you need to add a dependency. Let's go find an example of add dependency. So here we go. So this guy is coming from some piece of, so when there's several examples of this, but the one I've stumbled onto first is about migrating Hibernate constraints to Java X. And so this is both doing a change type for some Hibernate type in order to use the Java X constraint instead, but it also is going to add a dependency on Java X.validation so that there will be something on the class path to actually provide this symbol when this recipe is finished running. And let's see if I can zoom this in a little bit so you can see it better. There we go. So on the add dependency recipe, just like elsewhere, you specify, group artifact version, and, you can use version selectors like 2.x here. And there's this parameter I want to discuss because it's very useful and often not well understood by people who come in and start wanting to write migrations with Open Rewrite or use these dependency manipulation recipes. This only if using is a allows you to constrain this recipe to only make a change if somewhere in the code of this project, sorry, maybe spring allergies, feeling like I had to sneeze there for a second. Oh, all right, I did have to sneeze. So the only if using parameter lets you say, hey, only add this dependency if somewhere in the code you see a type that has this fully qualified name, with star to be a wildcard. Only add this dependency if you see a type in use somewhere in the code that has this fully qualified name. And this allows you to prevent adding dependencies to totally unrelated projects, right? Because if we go and run this recipe across a bunch of projects, and if there was, this guy is intended to migrate Hibernate constraints to Java X. If it added the dependency where it wasn't needed, that would be confusing. That would be noise. It would be something to filter out, and that's exactly what only if using does. It allows you to conditionally add dependencies. So that's cool. Um, Kind of related to adding dependencies is management of uh, your parent POM. It's very common in the Maven world, and this is something you don't quite have an equivalent for in Gradle, but it's very common in the Maven world to centralize common configuration of your projects into a parent POM. And for that, we have, there's change Maven parent, which is the implementation behind upgrade Maven parent, which is usually what you're doing if you're just changing out. You want to keep the same group artifact, but just want a new version for your Maven parent POM. Yeah, upgrade Maven parent project version is the simplified form of change Maven parent. But if you were to look under the hood, you'd see that upgrade Maven parent is just effectively a shorthand or a convenience for change Maven parent, which lets you do things like swap out one parent POM for another. And this is used pretty commonly in migrations. All right, it'd be upgrade parent is the one that's usually used. Upgrade parent version. Yeah, and so we see in here that this is used commonly inside of these migrations, alongside other dependency updates in order to upgrade, like Spring Boot Starter Parent to the latest. And then kind of on the Gradle side, it's not a perfect analogy to a Maven parent POM, but there is the upgrade plugin version recipe, which helps you to upgrade the versions of Gradle plugins that are in use throughout your project. And we have this update Gradle wrapper recipe as well, which, Gradle is always releasing new versions of their build tool. So let's see. So like just recently, they came out with, by recently, I literally mean 3 days ago, this past Friday, one business day ago, they released Gradle 8.7, which I haven't read through the release notes yet, but usually there's lots of good stuff in there. And support for building projects with Java 22. So if you're wanting to get in on the latest Java features, you'll want to upgrade your Gradle version. And so, this came out one business day ago, and all of our open rewrite repositories have already been updated to use it. As we go in here, yeah, we're already using Gradle 8.7, and that's because we just ran the upgrade Gradle wrapper recipe and ran that across all of our repositories and mass committed the results. So yeah, if I go back to the open rewrite, I look in here, then back on, here we go. Yeah, the update Gradle wrapper recipe ran, and most of the results are gone because we only store recipe results in memory, figuring that, hey, if you want, there's no need to have a durable record of results from a recipe from, last week. If you can just run the recipe again. But we already committed all the results from these, and we see that we updated both the jar, the binary file that gets checked in, as well as the most importantly the Gradle wrapper.properties file with the new with the new Gradle version. And so with the ability to upgrade your build plugins and your parent POMs and your Gradle version and all of your dependencies, these are kind of the building blocks that you need in order to handle the dependency side of things, handle the migration from one version of a library to another. And you can kind of see how you mix and match these building blocks together. As like to go from like Spring Boot 1 to Spring Boot 3, you would have to upgrade your Java version, upgrade the version of your build tool, upgrade all of your build plugins, upgrade your parent POMs, upgrade the dependencies accordingly. And so having the faculties to do each of these end up being really, really helpful for that, making automated migration possible. Let's see, and I specifically have been actually doing some work on some of these dependency management recipes recently. So like upgrade parent POM or upgrade parent, or not upgrade parent version, and change parent POM and change parent POM test. Just last week, I updated these guys to have some new functionality. See if I can find a test case that shows a good example. Or I know there's a test case in here. I just need to go find the one I'm thinking of. Yeah, here we go. Brings down managed version. So this is new functionality in change parent POM. So in this test case, for example, we're moving from Spring Boot dependencies 2.4.0 all the way up to Spring Boot dependencies 3.2.4. And there are, if we were to go look inside of these parent POMs, some properties that have changed in that time or gone away entirely. In version 2.4.0 of Spring Boot dependencies, Java X Servlet API had a managed dependency version in it. But in the newer version, in 3.2.4, they moved away from that and used some other dependency to provide that instead. So in order to keep the project building with this new parent POM, I have enhanced this change parent POM recipe to bring down into the child POM the properties that used to exist in the old version of the parent that no longer are defined in the new version of the parent. And so you can imagine how in some fully featured upgrade recipe, and I believe we do this in Rewrite Spring, you'd want some additional handling here in order to replace like the old Java X Servlet API with its appropriate modern replacement. But that building this into the recipe at least is much more likely to keep the project building and the code at least compiling while you undertake one of these transitions. And this is a scenario that some of our customers talk about a lot of, migrating to the latest version of the internal corporate parent POM. And the latest version is getting rid of some old properties or some old managed versions. and so you can kind of temporarily have this dependency management section added in here, so the project compiles as long as possible while you pursue seeing that migration through to its final conclusion of being all up to date on everything everywhere. Now, as a Maven user, you might look at this and think, "Hey, it's great that this keeps my project compiling now." Uh, but what if I want to move forward? Whenever I end up pinned to a version of a dependency, initially I might be pinning to the current version or pinning to a newer version than what might be supplied by a parent POM or dependency management or anything like that. But at some point, you might find with the passage of time that was previously a current version now becomes an old version. And the pin that used to mean that you were ahead of the curve is now keeping you stuck behind the curve. And that's part of why I also recently enhanced. Let's see, let's remove. Yeah, I also recently enhanced the remove redundant dependency versions recipe. That's this guy. Remove unnecessary dependent? No, that's a different one. What did I call you? Remove redundant explicit dependencies version. Remove redundant explicit. Yeah. So this guy, this remove redundant explicit dependency plugin versions, its options have also changed slightly in order to try to facilitate these scenarios where you're just like always kept up to date and always keep your dependencies moving forward. And the enhancement that I made here was if you have this only if versions match set to true. Well, sorry, I'm getting ahead of myself. So what this guy does is lets you say, hey, in a situation like the one, in a situation like this, where say the version here has been set to 401, but imagine that this parent POM was setting things to a newer version, 402 or whatever. You're like, well, this pin is now keeping me back in an older version. I would like to keep up to date. I would like to move to the newer version of this. You can use remove redundant dependency versions to get rid of that. And before last week, remove redundant dependency versions did not support removing old managed dependencies. It only worked on explicit dependency versions in your project file. And it could also work, or what I have enhanced it to do, is if the child POM manages a dependency version and that same version is managed, or that same dependency is managed in the parent, well, then we could get rid of the explicit managing of the child dependency version, or we could get rid of the explicit managing of the dependencies version in the child POM and just use the dependency manager from the parent if they either match exactly, if you set this to true, or if you set this to false, it will move you to the version in the parent POM or remove the child POM's dependency management if the version in the parent is newer than or equal to the version result in the child POM. So with these kind of two things together, you can see how you could use pinning dependency versions to move you forward. And then, periodically as time passes and what used to pin you forward is now pinning you back, you can use remove redundant explicit dependency and plugin versions to keep you from getting stuck in the past. And this also makes an excellent companion for find and fix vulnerable dependencies, which is one of our most important recipes, which compares all of your dependencies to what is available or what dependencies are known to the GitHub Security Advisory database to have potential security issues. So, and this includes the stuff from many sources, including the NIST database of vulnerabilities, which is the ultimate source of truth for those CVE numbers that we all know and love. And so, let's see, I'll go run this on. Let's go run this on Netflix and Spring again, because it has a nice mix of Maven and Gradle dependencies. or projects. And so this guy will probably in a moment start suggesting some changes. Here's Spring Pet Clinic. That's a good example project. So here we go. So this guy, if it sees that if you use a dependency that is known to be vulnerable, and the fix for that vulnerability is only a patch version away from where you currently are, it will add in. It will try to bump your dependency version, even of a transitive dependency. So this guy, transitively depends on Spring Core, and this is trying to bump it up from Spring 6.1 dot something in order to, you know, it's probably 6.1.0 or something, and this will bump it up to 6.1.3. And you can see how, at the time when I run this, this is fixing an issue. And then as time passes, 6.1.3 could end up being pinned back to an older version rather than pinning it to a newer version. And what today is a solution, tomorrow could be a problem. And that's exactly where the, remove redundant explicit dependency versions would come in here and get rid of this when it was no longer necessary. So yeah, look to those to kind of combo together nicely. And then let's see if we get any. Yeah, and then similarly for Gradle projects, we'll use the dependency constraints mechanism to manage the versions of transitive dependencies. And there we're able to use the because function, even note which CVE that transitive dependency version is being managed because of. One kind of neat little thing about this recipe is that we have this visualization that goes with it, the dependency vulnerability profile, which shows the how big a jump needs to be made to get from the version of the dependency you're on to the version of the dependency that has the fix. And whenever this finishes rendering, there we go. We see that across this set of vulnerabilities, across this set of repositories, that a plurality, if not an absolute majority, of dependency vulnerabilities require bumping of a patch version in order to fix. So that, like, if all you did was bump a bunch of patch versions, you could resolve a bunch of possible vulnerabilities that your code might be exposed to as a consequence of your software supply chain. And then the coloring on these bars reflects the criticality of that error, or of the vulnerability that was discovered in the transitive dependency closure. So in this case, you can see that there are 163 critical vulnerabilities according to the severity that's recorded in the database that could potentially be resolved or made into a non-issue just by bumping the patch versions of dependencies. So you start to see how a little automation could potentially go a long way in order to reducing your threat surface area in terms of keeping you up to date with all of this good stuff. Let's see. Oh, there's another cool thing. So that's so I think it's the dependency report recipe that this guy just lists all of the dependencies you have. Well, if you check include transitive, it'll do all the transitive dependencies. Let's just do direct dependencies for now. And let's see. And so Giver just wanted a manifest, kind of like an SBOM of all of your dependency, that being a software bill of materials across all of your projects. You could run something like this in order to, once we have some more results coming in, you get to a data table and an interactive visualization that'll show you once it's ready of all of your dependencies. So let's just let that run for a moment. Looks like it is queued. Just curious to check the activity view. It looks like I'm not the only one running recipes in this group, so there may be a little bit more contention for the worker processes as my recipe and Justine's recipe fight for resources, but that's fine. What we have in here to try to help everyone kind of fairly get recipe results when you have contention or multiple people using the system is, well, obviously some workers are queued waiting for a recipe to run on them. But if you have a very big repository, it will, whether it's thousands or tens of thousands of files, it will stop after every, I want to say, 1,000 files process and yield and give that worker a chance to work on some other piece of work, so that one big repository, having been scheduled for a big recipe run, will not starve other projects of resources. Okay, I've got results for at least some repositories now, so I'm just going to cancel the recipe run because just that will be good enough to look at the data tables and visualizations based on this. So in the data tables view, I can go over here and start downloading the dependency report. It's just going to keep going. And then what I really want to show you is this dependency tree view, which is this dependency tree view, which provides an interactive, searchable visualization of all of the dependencies in this project. So kind of going back to that example I started with of looking for Jackson stuff, this is you can filter in here and see that, the Spring Cloud group is bringing in, Jackson data bind 2.14.1 via Kafka via Kafka core, and that's what has the more or less direct Jackson data bind dependency, or it is direct because we're only including direct dependencies in this search. And if instead, so this view kind of lets me ask the question, what do I have that includes Jackson data bind, right? 24 projects in the Netflix organization, 48 projects under Spring Projects, 9 under Spring Experimental, 57 under Spring Cloud, all of that. If instead I want to look at the same data from the inverse, I click this reverse tree button and start from, Jackson data bind, each version of Jackson data bind at the top of its own tree, and then I can expand here, like, Jackson data bind 2.14.1, or 2.4.3. I expected these guys to be on a newer version, for example. Let's see what's including this version. Okay, that's coming from Netflix Q Master and Hollow JSON adapter, and so you can see from the opposite side what includes each dependency. And something like this you might compare to Eclipse is a pretty good dependency viewer that has similar functionality to this. So you might compare what we have here to that. And so yeah, these are some of the tools that you can use to manage dependencies with Open Rewrite recipes and with Moderne. You can add dependencies, you can add plugins, you can upgrade them, you can remove them, you can go to new parent palms, you can manage your plugin versions, you can update your Gradle, you can update your Maven. You can do all of these kind of fun and useful things, or if not fun, at least useful. It's fun when it works well, I suppose. Um, and kind of keep your software supply chain up to date with a fraction of the hassle and manual busy work that you would get from doing all of these same sorts of things manually. Okay, I think that's a pretty good primer on dependency manipulation in Open Rewrite and in Moderne. Join me next week on Wednesday, where I will be talking with Justine, our artificial intelligence researcher, who has implemented, amongst other things, a language model-based recipe search, which is why up here, it used to be when we only used Lucene for indexing recipes, you were only able to search for exact matches. And I personally, being used to that, I'm still in the habit of searching for the exact title of a recipe. But that AI or that language model based search that we have now that Justine implemented is why you can do things like, I don't know, just a recipe to improve Java code quality. You can do natural language queries, and it's going to suggest to you, Java recipe best practices, recipe testing best practices, nullability best practices, and so forth, trying to provide sensible suggestions to fuzzy matches based upon the names and descriptions of these recipes. Now, AI is hot right now, and so if you are looking to learn a little bit more about that, come check out my talk with Justine next Wednesday. And until then, I will see all of you who have any questions about recipe development or Open Rewrite or Moderne or any of that good stuff in our community, Slacks, and Discords. So thank you so much for attending. Don't forget to check out Jonathan Olga's presentation at DevNexus very soon, and I will see you all next week. Goodbye.